I never met the father of electricity. He died 51 years before I was born. He invented the electric motor. He invented the generator. Every power plant on Earth, every light switch, every phone charger, every hospital machine keeping someone alive runs on principles he discovered. And he could not do mathematics, not calculus, not trigonometry, not even algebra beyond the simplest operations. James Clerk Maxwell, one of the greatest mathematical physicists in history, looked at this man's work and said he was a mathematician of a very high order. How is that possible? Michael Faraday, a bookbinder's apprentice from the slums of London. Einstein kept 3 portraits on his study wall: Newton, Maxwell, and Faraday. Not a professor, not a Cambridge man, a boy who had almost no formal education, who invented words we still use today: electrode, cathode, anode, ion, and saw deeper into nature than the mathematicians who doubted him. That is the story I want to tell you. Faraday was born in 1791 in a village called Newington Butts, just outside London. His father, James, was a blacksmith, but not a successful one. He was often ill. He could barely provide for his family. There were 4 children. They were always hungry. Faraday later remembered being given 1 loaf of bread. 1 loaf. It had to last him an entire week. The loaf had to stretch across days and nights. This was not poverty as an abstraction. This was a child going to bed hungry, night after night, wondering if there would be food tomorrow. His education was almost nothing. A common day school where he learned to read, write, and do basic arithmetic. That was it. That was all the formal education Michael Faraday would ever receive. At 13, he had to start working. He became an errand boy for a bookbinder named George Rebow. After a year, Rebow made him an apprentice. And here is where everything changed. Because Faraday did not just bind the books. He read them. Every book that came through that shop, Faraday devoured. He would work all day binding pages together, and then stay up late reading what he had bound. One book seized his imagination: the Encyclopedia Britannica, specifically the article on electricity. He could not stop thinking about it. He started doing experiments in the back of the shop, building simple electrical devices with whatever materials he could scrounge. A bookbinder's apprentice, teaching himself science in a back room, with scraps. That is not supposed to work. The scientific establishment of 19th century England was a gentleman's club. You needed money. You needed connections. You needed a university degree. Faraday had none of these things. But he had something else. He had a way of seeing. In 1812, when Faraday was 20 years old, something miraculous happened. A customer named William Dance gave him tickets to attend lectures by Humphrey Davy at the Royal Institution. Davy was the most famous scientist in England, brilliant, charismatic, celebrated. He had discovered more chemical elements than anyone alive. For a poor apprentice from the slums, this was like being given tickets to meet God. Faraday attended 4 lectures. He took meticulous notes. Then he did something extraordinary. He bound those notes into a beautiful book, 300 pages of careful handwriting and illustrations, and sent it to Davy with a letter asking for a job in science. Can you imagine? A bookbinder's apprentice writing to the most famous scientist in England, saying, "I want to be like you." Most people would have thrown the letter away. Davy did not. He was impressed. He told Faraday to be patient, to wait for an opportunity. A few months later, Davy was injured in a laboratory explosion. Nitrogen trichloride blew up in his face, temporarily blinding him. He needed someone to take notes for him. He remembered the bookbinder's apprentice. Faraday got the job. In March 1813, Michael Faraday walked into the Royal Institution as a laboratory assistant. He was 21 years old. His salary was 1 guinea a week, with a room in the attic and candles for light. He had escaped the bookbinding shop. He had entered the world of science, but he had also entered the world of Humphrey Davy, and Davy would become both his salvation and his torment. Later that year, Davy took Faraday on a tour of Europe. They visited the greatest scientists on the continent, Volta in Italy, and Ampere in Paris. For a young man who had never left London, it was an education beyond anything he could have dreamed. But there was a problem. Davy's wife refused to treat Faraday as an equal. In her eyes, he was a servant, a lower-class nobody who should eat with the staff and ride outside the coach. For 18 months, Faraday endured this humiliation. He nearly quit several times, but he stayed because he knew this was his only chance. When they returned to London, Faraday threw himself into research. He worked on everything: chemistry, metallurgy, and optical glass. He discovered benzene. He invented an early version of the Bunsen burner. But his real passion was electricity. In 1821, Faraday made his first great electrical discovery. He showed that a wire carrying electric current could be made to rotate continuously around a magnet. This was the first electric motor. It was a simple device, just a wire, a magnet, and a battery. But the principle was revolutionary. For the first time in history, someone had converted electrical energy into continuous mechanical motion. Faraday published his results immediately, and then everything went wrong. Because Faraday had not properly acknowledged the work of others, including some ideas that Davy had discussed with his friend William Wollaston. The accusations came quickly: plagiarism, theft of ideas, and the loudest voice, Humphrey Davy. The man who had given Faraday his chance was now publicly attacking him. Think about what that must have felt like. The person who saved you from a life of bookbinding, the person you admired more than anyone, turning on you in public, calling you a thief. Faraday was devastated. He wrote to Wollaston, desperate to clear his name. "I am anxious to escape from unfounded impressions against me." Wollaston privately said he was not offended, but he never publicly defended Faraday. And Davy kept attacking. When Faraday was nominated for the Royal Society, the highest honor a British scientist could receive, Davy opposed him. He, the president of the Royal Society, was trying to block his own protege. The vote was nearly unanimous in Faraday's favor. Only one person voted against him. Everyone knew who it was. Why did Davy turn on him? The historical record suggests jealousy. Davy had discovered Faraday. He had plucked this nobody from a bookbinding shop and given him a life in science. But he had never expected the apprentice to become his equal. Now the student was threatening to surpass the master, and Davy could not bear it. Faraday was elected anyway, with nearly unanimous support despite Davy's opposition. But the relationship never recovered. For the next several years, Faraday avoided electromagnetic research. He worked on other projects: optical glass, steel alloys, and lighthouse improvements. He was waiting. In 1829, Humphrey Davy died, and Faraday returned to electricity. In 1831, Faraday made the discovery that would change the world. He had been thinking about a question for years. Everyone knew that electricity could create magnetism, pass a current through a wire, and you get a magnetic field. But could it work the other way? Could magnetism create electricity? Other scientists had tried and failed. Faraday tried something different. He wrapped 2 coils of wire around an iron ring. When he sent a pulse of current through one coil, a momentary current appeared in the other coil, even though the coils were not connected. At first, he thought it was a mistake. The effect only lasted an instant. But when he stopped the current, another pulse appeared in the opposite direction. Faraday realized what was happening. It was not the current itself that created the effect. It was the change. A changing magnetic field creates an electric current. Electromagnetic induction. He tested it again and again. He moved a magnet through a loop of wire. Current flowed. He moved the wire past a stationary magnet. Current flowed. It always worked. As long as something was changing, electricity appeared. This is the principle behind every generator, every transformer, every power plant on Earth. When you flip a light switch, you are using Faraday's discovery. When you charge your phone, you are using Faraday's discovery. When a wind turbine spins or a nuclear plant heats water to turn a turbine, they are using Faraday's discovery. The entire electrical infrastructure of modern civilization rests on what Faraday found in that laboratory in 1831. But Faraday did not stop there. He kept experimenting. He kept asking questions. And he began to see something that no one else could see. When Faraday looked at a magnet, he did not see a piece of metal with some mysterious property. He saw invisible lines of force radiating outward into space, filling the emptiness around the magnet with a kind of tension. He called them lines of force. We call them fields. This was a revolutionary idea, and most physicists thought it was nonsense. For 200 years, ever since Newton, everyone believed that forces acted at a distance. The sun pulls on the Earth across 93 million miles of empty space. A magnet here reaches out and pulls a piece of iron there. Nothing is in between. Space is empty. Faraday said no. He saw something filling that space. Invisible structures of force, curving and flowing around the magnet like water around a stone. Scatter iron filings near a magnet. Watch them arrange themselves into beautiful curved patterns. Those patterns are real. Something is making them curve. That something, Faraday said, is the field. Space is not empty. It is filled with these invisible lines of force. His colleagues were skeptical. Some were hostile. Fields? You cannot see a field. You cannot touch a field. How can empty space be filled with something? But Faraday trusted his experiments. He trusted what he saw with his own eyes. The patterns were real. The lines of force were real. Something was there. He just could not prove it mathematically, because Faraday could not do mathematics. His abilities did not extend to trigonometry and were limited to the simplest algebra. And here is where the story takes its final turn. A young Scottish physicist named James Clerk Maxwell read Faraday's papers and saw something extraordinary. Faraday's lines of force were not mysticism. They were a new way of seeing reality. And Maxwell realized he could translate Faraday's visual intuitions into precise mathematical language. It took Maxwell years, but when he was done, he had 4 equations. The Maxwell equations that unified electricity, magnetism, and light into a single theory. And here is what Maxwell said about Faraday. The way in which Faraday made use of his idea shows him to have been in reality a mathematician of a very high order, one from whom the mathematicians of the future may derive valuable and fertile methods. A mathematician of a very high order. Faraday could not write an equation to save his life, but he thought in pictures so clearly, so deeply, that a genius like Maxwell could look at his work and see mathematics hidden inside. When Einstein visited Cambridge in 1922, his host told him he had done great things because he stood on Newton's shoulders. Einstein replied, "No, I don't. I stand on the shoulders of Maxwell." But Maxwell stood on the shoulders of Faraday. The man who could not do math had seen deeper into the nature of reality than the mathematicians who doubted him. In his later years, Faraday's mind began to fail. His memory faded. He would forget what he had said moments before. He could no longer give lectures, and he could no longer do research. The man who had devoted his entire life to understanding nature could no longer remember his own discoveries. Queen Victoria offered him a grace and favor house at Hampton Court, a quiet place to live out his final years. Faraday accepted gratefully. He had been offered a knighthood. He refused. He had been offered the presidency of the Royal Society twice. He refused both times. He wanted no titles, no honors. He wanted only what he had always wanted, to understand how nature worked. On August 25th, 1867, Michael Faraday died peacefully in his chair at Hampton Court. He was 75 years old. He was offered burial in Westminster Abbey, next to Isaac Newton, the highest honor England could give a scientist. He refused that too. He was buried instead in a simple grave at Highgate Cemetery, with only a small headstone. No grand monument, no elaborate tomb, just his name and the dates of his life. But here is what I want you to remember. This was a boy who went hungry, a boy who had almost no schooling, a boy who bound books for a living because his family had nothing. And he saw things that the greatest minds of his age could not see. He invented the electric motor. He discovered electromagnetic induction. He gave us the concept of the field, the idea that would transform physics from Newton's world of forces at a distance into Einstein's world of curved space-time. He did all of this without mathematics. They call him the father of electricity. And they are right. Einstein kept 3 portraits on his study wall. Newton, the founder of physics. Maxwell, who unified electricity and light. And Faraday, The blacksmith's son who could not do math but saw deeper into nature than anyone. I never met him, but I stand on his shoulders. Maxwell stood on his shoulders. Einstein stood on his shoulders. Every time you flip a light switch, every time you use anything electrical, you are using what Faraday discovered. He changed the world without ever knowing how much it would change. And he did it all by asking one simple question: how does it work? I have spent my life surrounded by extraordinary minds. If you want to hear their stories, you know where to find me.